Chapter 4 takes us into proofs. And what proofs are is basically just justifying why you're doing something. So the reason you took all these notes on the Ed puzzle was to get us through just the basic things you used to do or still do whenever you do algebra. The rules for why we solve the way we solved. Why did we do that? And we went through all these different properties, you matched them up, is because when we do proofs in geometry, it can take a bunch of different forms. One of the forms is if you are given something, so this is on page 2 of that packet, if you turn the page. If you're given a piece of information and then you're asked to prove something, lots of times they'll give you a picture. And then we kind of go through this whole list of statements that go from, here's what I know to be true, here's what I can look at and say, okay, all of these other things are true because I started out here. But whenever we say something, we have to have a reason behind it. So our 2-column proof is a column of statements and a column of reasons. Reasons why we can say what we wanted to say. So what we are going to do here is kind of start us off on proofs a little less geometric, but a little bit more algebra based to kind of get your feet wet and be like, okay, you do know what you're doing to do a proof because all you're going to do is tell me why I can do the steps I'm doing. Okay? When we do proofs in here, in class, a lot of times we're going to write the statements and the reasons down. When you do them on your homework, when you do them on a test or a quiz, you are only going to have to give me the reasons. Okay, if you have friends that are in the honors class, they do both sides. I take this one back a level and I tell you what the steps are because there's a lot of different paths you can take. I want us all to be on the same path of here's what we're trying to say. I just want you to be able to tell me why we can say it. Okay, so when I start with algebra ones, I'm going to start us with a geometry concept and then work us through the algebra that would help us solve for x. So kind of like what you've already done on tests and quizzes for me, where you've looked at a geometry picture and you set up an algebra equation and solve for x. We're just going to do that. So for instance, on this first one, it tells us angle AOC is 139 degrees. And then it gives us in the picture those two little angles are x and 2x plus 10. What do we do to set up an equation to solve for x on this problem? It's a chapter 1 question. Yeah. Just throw it out there. Anything's better than nothing right now. Give me a shot. Absolutely. Okay, what she said was she took the two x's, added them together, and said plus 10 gives me 139. That's absolutely where we're going to head. I'm going to back us up 2 steps. Why can we get to this and this equaling that? What are you doing? What's the geometry thing that let us do that? What are we adding together? You're going to add the like terms, back up another step. What objects are we adding together? To what? What are these things called? Angles. We're adding 2 angles together to get to AOC, which is this entire angle. Back in chapter 1, we had a name for that. They're angles. We're adding them. It was the angle addition postulate. So what we're going to do for our first statement is we're going to write out what it is in geometry before we put in the measures that are there in algebra. So it's 100% the right thing you guys were talking about doing. I'm just backing us up a couple steps. The geometry statement would be that angle AOB plus angle BOC equals angle AOC. So if I take angle AOB, little one on the top, I add BOC, which is a little one on the bottom, put them together, it gives me the whole angle, angle AOC. And we did that because we know that we can take the 2 little parts and add them together because of the angle addition postulate. The further we get into proofs, the more you will abbreviate. Usually I put an angle symbol there, the word add, and then post. So angle symbol for angle, add for addition, post for postulate. And I'm 100% fine with that. As long as I can understand what your abbreviation means, you can abbreviate. You don't need to write out entire words. Okay, so now we're going to throw it to the algebra. You had gotten to the add the like terms part. Let's take it a step back. What are the actual angles that we're adding up? What's AOB? It's in its spot. X, absolutely. What is BOC? What's AOC? Nope. What do we have up here for AOC? 139. Okay. So from the Ed puzzle, what is it called when I put something in place of what it's equal to? Substitution. Absolutely. So we took the x, we put it in place of AOB because it was equal to it. We took 2x plus 10, put it in place of BOC because it was equal to it. And we took 139 and put it in place of AOC because it was equal to it. Whenever you replace something with what it's equal to, it's substitution. Okay, now let's take that next step. What do we do next algebraically? Combine the like terms, absolutely. So we get a 3x plus 10 equals 139, and you just gave me my reason. What did we do to get to that 3x? Combine like terms. You can write combine like terms, you can write add like terms, however you want to phrase it. But don't just leave it adding, because that just adding is when we add the same thing to both sides of the equation. But because we put those two together and they were like terms, we're adding like terms or combining like terms. Specific wording, I don't care as long as you have the idea behind it. All right, algebraically, what's my next step? Subtract 10 from both sides. So do we already know what the reason's going to be? Yeah, the reason you just told me is going to be subtract. What do I get algebraically when I do that subtraction? Perfect. 3x equals 129. So when we're doing our reasons, you're telling me, how did I get to this step? How did I go from step 3 to step 4? I subtracted 10. So my reason is subtraction. And then last but not least, what would x be? And you just told me we would divide. Absolutely, there's my reason. How much is x? So you just did your first geometry proof. We did it based off a geometry concept, but threw in the algebra to kind of get your feet wet on how am I doing these proofs. All we're doing is saying, why can I move to the next step? And when you think about this real world, in your head you're going, I'm never going to do this. There is no reason that I would ever have to tell somebody the steps of a geometry proof. Unless you're a math teacher, you're 100% right. You will never use this exact thing. But I can guarantee you at some point in your life, you are going to have to give someone directions. You're going to have to tell them how to get from point A to point Z. And maybe not take 26 steps to do it, but you're going to have to guide them through a process. Or, hopefully not, but someday you get pulled over by a cop. And they want to know what happened, why, and how. Probably in the opposite order. How first and then why. You're going to have to describe something step by step by step and give the reasons behind why you did what you did. I pulled over here because this person did this. That's a proof. My job as a teacher is to give you skills, and working through a process step by step by step and being able to explain that step by step by step, that's a life skill. Okay? So I guarantee you, geometry-wise, you might not ever have to explain why triangles are congruent. That's where we're headed next. But real life-wise, you're going to have to explain yourself and explain processes to people and have people follow directions in order to get through something. So wrap your head around the geometry, but realize what you're doing is building a life skill of how to tell somebody what happened and how. All right, we're going to do another geometry one. Start out with a geometry concept, end in an algebra proof. Up above there, it tells me that ray LM bisects angle KLN. What does bisects mean? Splits it in any particular two? Uh-huh. Okay, so bisects tells us it's going to split us into 2 equal halves. The word bisect being in my given tells me that I'm probably going to see a definition of bisects. It's probably going to guide me in this proof. So my very first step, whenever you have some piece of information given to you, is to write down the given. So I'm going to write down ray LM bisects angle KLN. And my reason is because it was given to me. So I just write given. It's information we knew up front. Okay. So knowing that it cuts it into 2 equal halves, what geometry statement can you tell me? Or what piece of information does that help me with in the picture? Perfect. Angle KLM, I'm going to use a geometry term of G congruent to angle MLN. What told us they were equal? It said bisect. And when you can look at me and say, because it said bisect, that's a definition. So I write def of bisect, def for definition. Yeah. Say that one more time for me. Would it transfer to KLM? In a way, yes. I think you're telling me my next step without telling me my next step. So KLM and MLN are congruent. So what she's saying is if they're equal halves, wouldn't this 4x be up here too? Is that what you're saying? Absolutely. What's my next step? What can I do with that congruent statement and the algebra that we have in the picture? What would you do if you were doing it on a test? How would you solve for x? What equation would you set up? I don't think we're going to combine them. Set them equal to each other, which is what we said in number 2, right? KLM is 2x plus 40. MLN is the 4x. What is it called when we put something in place of what it's equal to? Substitution. Oh, wait. One thing I forgot to mention on the last one. Remember on the last one we had a substitution line and we had a subtraction line, right? And I told you you can abbreviate words. But I cannot abbreviate to sub. Because sub is subtraction and substitution. So if you're going to abbreviate, give me an extra letter. It can be sub T and sub S or sub st. I don't care if you shorten those words, but make sure you don't shorten them both to sub, because then I can't tell which is which. So you got to give me an extra letter. So if you were going to do that here, you could have just done that if you wanted. Okay? But you got to have an extra letter past the B. All right. Next algebra step is what? Subtract the 2x. So when we get here, we know this is going to be subtraction. What is my step that I end at? After I subtract the 2x, what do I have sitting here? Absolutely. So the thing is in proofs, They oftentimes don't write out what mathematical step is happening. They just write what's left after you do that step. So then last but not least, step 5 would be divide it. Absolutely. What would my answer be or my statement be? Nice. Okay, so geometry concept there was knowing what the word bisects meant, so that we could write a geometry statement of angle KLM congruent to angle MLN, then we could substitute in the algebra and tell why each step of the algebra happened. Okay, one more. One more algebra E1. What do we know about this segment? Yeah. It's a segment, because lines go on forever. This one's a segment, so it ends. What else do we know? Yeah. The whole thing is 21. Okay? Think algebra for a minute. What would you do? How would you get y? Did this. Perfect. 2y plus 3y minus 9 equals 21. That's what you would do back in chapter 1 when I just said just solve it. So let's back up one step, because you just gave me this one. What is the geometry statement that would follow from? What did you add together? The two-line segment. So we added AB and BC and got AC. What did we add together? Segments. Remember when we had the angles, what the reason was? Angle addition postulate. So this, instead of angle addition postulate, is? What are we adding? Segments. Segment addition postulate. And we kind of worked it backwards. We gave the algebra and then gave the geometry. But if we went the other way, starting at geometry, going to the algebra, what did we do to put that 2y in place of AB? I heard substitution. Absolutely. Sometimes when I run out of room on my paper, I write substitute instead of substitution. It's all good. What I'm trying to find out here is if you have a general idea of what terms you would use, what my reasonings are behind it. Now what do we do? You can combine them. What are we combining? You said we were combining. What are we combining? Because that's my reason. Combining like terms. Somebody new, give me the next step. Subtract 9. It's subtracting right now. You sure you want to subtract it? We want to add it. So we're going to get 5y equals. And we added. This is why you can't leave add like terms as just add. Adding is when you put the same thing on both sides. So we added 9 to both sides to get to that 5y equals 30. Someone else give me the last one. You divide 30 by 5. So somebody new, tell me what I get. Yep. And you said divide. Yes, ma'am. Yes, so we're basing them off of these geometric or these algebra proofs that were based off of something geometric. The first step is the geometry one. But what we're going to do now is move to almost all geometry. And that's where we're heading throughout this entire chapter. So we are given triangle EFG with a right angle, angle F. We're trying to prove that angle E and angle G are complementary. What's complementary mean? Back to chapter 1. Can't forget anything in this class. I keep using it over and over and over again. They add up to 90. What does the right angle tell me? That we have a 90 degrees. Okay. When you start a proof in geometry, you want to look at the words that are given to you and that you're trying to get to. Because at some point in your proof, if there is a word in a given, you're probably going to see the definition of it. If there's a word in where your last statement will be, which is what you're trying to prove, it's always going to be in the last spot. There's probably a definition of that to get to that last spot. Okay? You cannot use the definition until after the word is used in some form. So our reasons, as we go through, because now I've got all the steps there for you. I'm starting with triangle EFG with a right angle angle F. How do I know that that's true? Where did you see it? In the given. So when you see it in the given, you just write it's given. So what we have to do when you're doing geometric proofs is you have to think about what that statement told us. We were told you had a triangle. So you know how many degrees are in a triangle? 180. We know we have a right angle. We already said that meant 90. That right angle is angle F. So why can I tell you that the measure of angle F is 90? Because it's a right angle. Whenever you say because it's this, that's the definition. Because it's a right angle, that means that's my definition of a right angle. Because you knew it was 90 because it was right. We go back to what is a right angle? It's a 90-degree angle. Definition. Okay, definitions can go both directions. I started with the word right angle and said it was 90 degrees. I could have started with it being 90 degrees and then said it was a right angle, and definition goes both of those reasons. All right. Now we have our next statement. The measure of angle E plus measure of angle F plus the measure of angle G is equal to 180. Where does that come from? Triangle angles add up to 180. Remember I said I abbreviate a lot? I just drew a triangle and put an S next to it. Triangles equal 180. So you can shorten these phrases as long as we can tell what they mean. All right, so we knew the right angle because it said right angle, so we know that's 90. We know triangles add up to 180. How are we moving from step 3 to step 4? The measure of angle E plus the measure of angle 90 plus the measure of angle 60. Oops, random number, sorry. Measure of angle E plus 90 plus the measure of angle G is 180. How do I go from step 3 to step 4? They replaced F with the actual amount. What's it called when we replace something with what it's equal to? We substitute it. Nice. So as you're sitting there trying to think through proofs, you're asking yourself, how did I go from this step to the next step? What changed and why did it change? This changed because the 90 was there instead of the F. It changed because we know they're equal to each other. That's a substitute. Okay, now how are we getting from step 4 to step 5? Now I have E plus G is 90. We subtract. What did we subtract? Subtracted the 90 from both sides. That's our subtraction. So again, they didn't actually write out, or I didn't write out, what I was doing. I just did the subtraction and told you what was left. We subtracted that 90 off of both sides. All right, so we've gotten to our prove statement. My prove statement is always the last one, never before that. And no, you can't write the word prove as its reason. Why are E and G complementary? What is the measure of angle E plus the measure of angle G? Why are they complementary? Because they equal 90. When you say because they're this, that's a definition. What's the definition of? Complementary. We could run the definition the opposite direction. We took the actual definition and put the word to it. When we did it with right angle, we had the word and we gave the definition to say it was 90. Now we have the definition, E and G add up to 90, and we're telling them in the proof, or telling whoever in the proof, that that's because it's complementary. That's the definition of complementary again. So definitions can go either direction. Okay? All right. So this next one, the proof is all screwed up. The statements are in the right order, but the reasons are mixed up. You're given triangle BCA is congruent to triangle CDE, and triangle CDE is congruent to triangle EGF. What does congruent mean? Same. What's the same? Two triangles are congruent. What's going to be the same in those triangles? Segments are, and angles. Because those are the parts of your congruent triangles, right? You either have segments or you have angles. That's the only thing that exists in a triangle. So being congruent means our parts are congruent. We're trying to prove that C is the midpoint of segment BD and E is the midpoint of segment DG. What does midpoint mean? It's in the exact middle of a segment. So a point that's in the middle of a segment. If it's in the middle of the segment, what do we know about the two parts on either side of it? They're equal. Okay. Why do I ask you all these questions? This is the thought process you need to go through when you start a proof. You need to stop and think about, what is this thing they told me is true? What does that mean? And where am I trying to get? What does it mean to have a midpoint? So you want to think through that before you start doing the statements and the reasons, because otherwise you're not going to have there's no continuity to it. If it's just each step on its own, the whole thing doesn't make sense together. So you got to think through it ahead of time. All right, again, these statements are in the right order. Number one statement is BCA is congruent to triangle CDE, and triangle CDE is congruent to triangle EGF. My reasons are not in the correct order. What reason should I have for that first statement? The given. That is exactly the same as what was up here. All right. Now we have segment BC is congruent to segment CD. And something you'll want to do as you're doing proofs is mark things on your picture. So BC is congruent to CD, and segment DE is congruent to segment EG. So I just put tick marks on my picture to show myself what that statement told me. Why can I say, just knowing that the triangles are congruent, that those segments are equal? Somebody new try. It's a 50-50 shot. We've been told the triangles are congruent. That's all I know. How come those parts are equal? Listen to my phrasing. We've been told the triangles are congruent. Why are those parts of the triangles congruent? Turn and talk to somebody next to you. See what you think. You got a 50-50 shot. Let's see if you can work it out between the two of you. You're going to hold up 1 if you think the answer is A, and you're going to hold up 3 if you think the answer is C. Hold up a hand. Everybody's got a hand up. I don't care who you look at or whatever, but either put 1 for A or 3 for C. Everybody needs a hand up, please. 1 for A or 3 for C. Pick an answer. Take a shot. You guys are good. It is C. Nice work. You were told you had congruent triangles. Those are congruent polygons, so their parts are congruent. Which leads us to the last one where C is the midpoint of BD and E is the midpoint of DG, because what did we know about the two segments on either side of that point? They're congruent, which is what we just saw on this picture. So definition of midpoint is our last one. Good. The next proof tells us that angle 1 and angle 2 are vertical angles. What does it mean to be vertical angles? Or what do vertical angles look like? Where are they located? If you need to use your hands to show me, you can do that. What do we see in a picture when there's vertical angles there? An X, absolutely. And those vertical angles, are they next to each other in the X or across from each other in the X? Okay, so all this told us is they were vertical angles. We know they're across from each other in the X. We're trying to prove that they're congruent. Now back in chapter 1 we did, right? We've been using vertical angles are congruent this whole time. But in chapter 1, when we did it by measuring it with a protractor on a piece of paper. We had to have the actual thing there and have a protractor in our hand and said, okay, now we know these are equal. What we're going to do now is the geometry proof behind that lets us say that without actually having to pick up a protractor. Okay, so we're given angle 1 and angle 2 are vertical angles. It's a given. What do you think the word linear pair means? Because our next thing says angle 1 and 3 are a linear pair. And angle 2 and 3 are a linear pair. Those angles fall on the same line. And they make an actual line together. Okay? So what that could be is definition of linear pair. Because I'm looking at the picture, I can see that those two angles together make that same line. A different way of saying it, if you don't like this definition of linear pair, because we just kind of free-handed that definition, it's just those two angles form a line. If that's an easier way to remember it. I don't care which way you say that one. All right. Then step 3 says the measure of angle 1 plus the measure of angle 3 is 180. This is back to chapter 1. What are we doing? They're supplementary angles, so we know if we add the two little parts, we get to the whole, right? What did we say at the beginning of this lesson? How do we add two little angles and get to a whole angle? It was a postulate. There you go. We're adding the two little ones to get to the whole. So that's my angle addition postulate. Again, remember I said I start to abbreviate. I don't like writing as much as you don't like writing. So then how much, or why did 2 and 3 add up to 180? Well, we don't know angle 1 and angle 2 are congruent yet. We only know what's been said in the proof. We know angle 1 and 3 are a linear pair. We know 2 and 3 are a linear pair. How come we knew 1 and 3 added up to 180? What was our reason for that? You have it written on your page. What's the reason 3? Angle addition postulate. Why do we know angle 2 and angle 3 equal 180? Absolutely, it's angle addition postulate. So we took linear pair, we went to adding them up equal to 180. Linear pair, add them up equal 180. It's angle addition postulate again. Sometimes when proofs are written out for you, they will put those two in one step because it's the same reason, so why write it twice? Sometimes we'll put them in separate because we need them at separate parts during the proof. But you can use the same reason more than one time, which is why I did it twice like that. Because sometimes we'll manipulate one and then we'll put the other one after that. All right. Angle 1 plus angle 3 is equal to the measure of angle 2 plus the measure of angle 3. Why do I know those are equal? Turn to somebody near you. Talk about why you think those could be equal. All right, what are we thinking? Saw a lot of, I don't know. Okay? You got to stop at that cop out and actually stop and look at what you've been given and see if there's some way you can come up with a reason. What possible reason could we have for those two chunks? 1 and 3 being equal to 2 and 3. They're both equal to 180. They both have that same value, right? So what is it called when I put something in place of what it's equal to? There you go. So sometimes it's not looking for specific words, it's just kind of trying to think it through. Why could these be equal to each other? Well, they both equal 180. Oh, I can substitute that. All right, here's the big question. How do I then get it to angle 1 is congruent to angle 2? What changed from step 5 to step 6? What changed? What's not there that was there in step 5? Okay, the equal sign went to a congruence. Good. What else? Angle 3. Where did angle 3 go? How did angle 3 disappear? You subtracted it. So what's my reason for angle 1 being congruent to angle 2? Subtraction. So a lot of times it's literally just looking at it and going, okay, what possibly could have happened from this step to this step? What went away? What's not there or what changed? What is there now that wasn't there before? And you stop and think, okay, why could I put it in that place? That's what happened on step 5. What is there now that wasn't before? Well, 1 and 3 was already there. But now all of a sudden it's 2 and 3 on the other side. How did that happen? It happened because they're both equal to 180. Where did angle 3 go? Well, it was on both sides. For it to go away, it was being added on both sides. The only way to make it go away is to subtract it on both sides. So that's subtraction. And that's the basic gist behind a two-column proof. We have to stop and think, how can I go from one step to the next? Sorry. How can I go from one step to the next and give a reason behind it? What was my reasoning for moving to that next step? But that's the only format that proofs can take. Proofs can also be written as a paragraph. But when we write a paragraph, what we do is essentially just take the two-column proof and write it out in sentences. Okay, we use some English connecting words. When we do that, we leave out the obvious reasons, words like given. Because if you were in just a general statement, reading in a book, you would not say that angle 1 and 2 are vertical angles because it's given to you. No, you would just say angle 1 and angle 2 are vertical angles. The fact that you wrote this sentence makes it given. So we don't put the word in like given. We don't put words like definition of. So again, if you said like that one, we're going to do this one where we have the right angle is at angle F. If I look at you and say angle F is a right angle and therefore it's 90 degrees. Do I need to tell you because that's the definition of a right angle? Or do you really understand that from the fact that I said it's a right angle so it's 90? If you can understand it from the wording, then you don't put the extra words in there. I don't need to take the time to write because that's the definition of a right angle, because you knew it, okay? So what we're going to do is take that first proof that we did, and I have it up here on the smartboard with us so you don't have to flip back and forth, where we knew that the triangle had a right angle at angle F, and we were trying to prove E and G were complementary. We're going to turn it into a paragraph proof. Again, all this really does is take your statements and reasons and write them into a paragraph, write them into sentences. So my very first sentence is going to be triangle EFG has a right angle at angle F. So we're writing out sentences. What did we know because it was a right angle? Okay. Give me an English connecting word that would go from it's a right angle and then that makes its measure 90. One of those fancy words you'd use in English class to connect things. Because would be at the beginning. So because it's a right angle, then it's 90 degrees. But I already got this first part written, so give me one that would go after. Therefore, angle F is 90. So I don't need to write definition of right angle, because the therefore took care of that part for me. Okay, so the next step was angle E plus angle F plus angle G equals 180, because triangles equal 180. Let's put that in a sentence. Could almost do it like I said it, or we can move it around a little bit. What do you want to do? Put that statement and reason together in a sentence. Turn to somebody next to you. Tell them what sentence you think it could be. To just take statement 3, E plus F plus G equals 180, and reason triangles equal 180 together into a sentence. All right, so somebody new, throw me out a statement here. Give me a sentence. Something you just said with people next to you. This is a completely free and open conversation here. You do not need to be worried that what you say is wrong. You're writing a paragraph. How often are you told you're wrong when you write a paragraph? I just need a sentence. Somebody new, talk to me. Otherwise, I start calling on people. Because? There you go. Measure angle E plus measure of angle F plus measure of angle G equals 180 because triangles equal 180. So I think you were all in your head making that a little bit harder than it really was. Because all I really wanted you just to do is connect those two, that statement, that reason, with some kind of connecting word. All right, my next statement, my next two statements, we could kind of condense. We went from E plus F plus G equals 180 to E plus 90 plus G equals 180. Because we substituted the 90. And then we subtracted that 90 out to get to E and G equaling 90. How could we say that. How could I put that in a sentence? Take what I just said we did and put it into a sentence. What did we substitute? 90 for what? By substituting 90 for the measure of angle F. What do we get? What do we get when we substitute 90 in for angle F? Put it right here. What does it look like? Put the 90 in place of angle F. Tell me what you have listed there then. Did measure of angle E change? Okay, so we have measure of angle E. What's my next thing that I would have? Plus 90, thank you. Keep going. Equals 180. What do we do next? Give me the algebra step. Because my next step in the proof was E plus G equals 90. If we subtract 90 from both sides, what do we get? What does that mean if those two angles add up to 90? Therefore, you could use a different word if you like something better than therefore. Angle E and angle G are complementary. I don't need to write definition of because we said it. We said they add up to 90, therefore they're complementary. So in reality, what I did was just take that proof and write out in sentences, and the only thing I didn't do is write things like definition of. I just tried to connect them with the words you would connect them with in an English paragraph. Questions there? Hold for a second because I still got people finishing. Yeah. All right, the next one we're going to do is we're going to take that one that was the mixed up proof from the page before, where we had the triangles that were congruent. We're going to write that one out in sentences. So if you are waiting here for people to finish on this one, go ahead and you can look back at that proof on the previous page. See if you can think of a way to start it. So the mixed up proof on the bottom of the page before. How can we start? I got it up on the smartboard. You got it on the bottom of the previous page. What's the first sentence going to look like? In other words, what's the first statement? I see lots of people writing. Can somebody tell me what they're writing? Perfect. Triangle BCA is congruent to CD, and triangle CD is congruent to triangle EGF. Okay? That one. The next statement said definition of congruent polygons. But we don't write the word definition. What do we know since the triangles are congruent? What was our next statement? What was statement 2? Again, it's on the previous page for you. It's up on the smartboard also. What was statement 2? Okay, so segment BC is congruent to segment CD, and segment D is congruent to segment EG. Why? Because what was true about the triangles? They were congruent. So because the triangles are congruent, BC is congruent to CD, and DE is congruent to EG. So I didn't say definition, I just said because they were congruent, now I know this. Once we knew those parts were equal, what did we know? Statement 3. What was point G or point C? Okay, so because the parts are equal, C is the midpoint. And E is the midpoint of DG. So again, just literally taking the statements and reasons and putting them in a sentence, but not saying the word definition, not saying the word given. On the next page, I have a paragraph proof written out for you. We're going to fill in the blank. We are given angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary. We're trying to prove angle 1 is congruent to angle 3. What does the word supplementary mean? Add up to 180. All right, so paragraph proof says since angle 1 and 2 are supplementary and so are angle 3 and 2, measure of angle 1 plus measure of angle 2 equals, and measure of angle 3 plus measure of angle 2 equals. They're both supplementary, they both equal 180. Then measure of angle 1 plus measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. How does that happen? We've done it once before today. Why would they be equal to each other? Substitute them because they both equal 180. So by substitution. Subtracting the measure of angle 2 from each side, you get measure of angle 1 is equal to come on. Angle 3. And saying their measures are equal is the same as saying the angles are congruent. So we know that angle 1 is congruent to angle 3. And what we just did a proof of, geometric proof proves it for all times, is the congruent supplements theorem. If two angles are supplementary of the same angle or are supplements of the same angle, then they are congruent. What would change if I told you 1 and 2 were complementary and 3 and 2 were complementary? What would change in that proof? You changed 180 to 90. Would anything else change? So we also have a congruent complements theorem, which says if two angles are complements of the same angle, then they are congruent. Because the only thing that would change in that proof would we would have 90s instead of 180s, but we'd still be able to set them equal to each other. We'd still be able to subtract that same angle from both sides. We'd end up with them being congruent. Okay, so we had two theorems there. One was supplements, one was complements. We did the supplements proof. You might see the complements proof coming to you later this evening or tomorrow, depending on when you do your homework. So be prepared for it, but you know it. All you got to do is switch your 180s to 90s. All right, here's a big earth-shattering theorem right here. Geometry likes to do this to you. What do you know about all right angles? How much do they equal? And since they all equal 90, all right angles are congruent. Bet you didn't know that one. In that space below there, while you are waiting for others to finish writing down all right angles are congruent, please draw me two angles that are congruent and supplementary. Two angles that are congruent and supplementary. What's supplementary again? 180. You'd actually be putting your pencil on your paper and drawing me two angles that are congruent and equal 180. Turn to the people next to you, see if your pictures look the same. All right, what'd you draw? Two what angles? Two right angles. Did you draw them separately or together? So like this, and this maybe? Did anybody draw it a different way? What'd you do? Absolutely, but no matter what, we had two right angles, right? So if, this is theorem 2.5, if two angles are congruent and supplementary, then each is a right angle. If two angles are congruent and supplementary, then each angle is a right angle. All right, the last two problems we have to do take you back more towards the algebra kind of stuff that you're used to doing and a little less in the proofs area. So as you're waiting for others to finish up, turn to that back page if you're done writing this side, and then start thinking about how you would find x and or y. Check with people around you, see what they're thinking to find either X or for Y. They're shaking your head. Realize this is chapter 1. You already did questions like this on a test. You know how to do these. All right, somebody give me an idea what to do. Come on. I've done these problems on a test already. Take a chance. Just 2 lines making an X. I think we have some angles that are formed then, don't we? Very nice. You got vertical angles. Which tells me X is what? 35, absolutely, because you subtract your 3X. Okay? Now what? I got to find X, Y, and the angles. You could substitute 35 for X and get there's that one. If I do it over here, what do I get? It's a good thing because they should be equal, right? How am I going to get a Y? Go. Because they form a line. How am I going to solve that one? Come on. Thank you. So 2y equals 40. What's y? And so that means we know this angle is? Because I had up to 180, or you plug the 20 in, whichever way you want to look at it. Good? That's all review right there. The last one we're going to do, we're doing with guess and check. Everybody good here? So it tells me that angle A is 3 times as large as its supplement to angle B, and we need to find the angles. What does that mean? It's 3 times as large as its supplement. What do we know about these angles? Supplement. What's that mean? It's going to add up to 180. So I know that angle B and angle A have to equal 180. What else do I know? If you're going to do algebra, absolutely you would do 180 divided by 4. We're going to do it with guess and check. You could do this algebraically. Why divide by 4? Absolutely. A is 3 times angle B. Okay, so we're going to do it with guess and check. Pick me a number for angle B. Give me an angle, any angle. Just guessed it, didn't you? We're going to do a little bit of guess and check before we get there. We'll get there. Let's say I make it 40. What's 3 times 40? Does that give me 180? It's too low, right? So in guess and check land, if I'm too low, I got to make my guess bigger. Let's say I make it 50. What's 3 times it? Now I'm too high because that's 200. So now I'm going to go 45. What's 3 times 45? Anybody? Thank you. Which is, when I add that to 45, 180, and we say, yay, we got it. Angle B is 45. Angle A is 135. Now, if you are an algebra person and you decide that you prefer to do it algebraically, as long as you show me the algebra work, show me what you did to get your angles, I'm fine with that. If you don't like the guess and check part. All right. Your homework is worksheet 4.1. Before you do that, I'm going to have you get into groups and at least do one of the envelopes in this packet that I give your group. What it's doing is it's going to give you a proof, and it's going to give you all the reasons, and you got to kind of sort out the reasons to go to whatever step it would be on the proof. Okay? I want to at least do one for everybody just so you get a little practice of you doing it rather than me doing it with you. After your group has checked that one, then I will hand out assignments after that. Okay? So find yourself a group. I have the capability of 6 groups. So we will figure out the numbers on that in just one moment.